I'm the global marketing director for the industrial automation and robotics market. And we'll talk today about the role of sensors in the Internet of Things. So we will touch on those two topics. And to get started, first, some of you, I'm sure, realize, but maybe not, how many sensors we're using already in our day-to-day life as we use navigation systems, whether it's in our handset or in your car, location-based services, gaming devices like tablets or again, smartphones, healthcare monitoring. Another example where you want to monitor your vital signs, like your heartbeat or how many calories you burn. So all those devices contain sensors. Those sensors are measuring acceleration, accelerometers. They're measuring a magnetic field, so we call those magnetosensors or magnetometers. We also have pressure sensors, gyroscopes. You can also detect light. You have touch sensors. You can use camera also to sense things. So there's lots of signals you can capture, and that those devices are capturing today. Those devices are more and more smaller in size. For instance, today we can put a 3-axis accelerometers in a small device, 2 by 2 millimeters. So it's very, very small form factor, and you can put that in any kind of device. And this is mainly driven by the smartphone market that needs always smaller and smaller device to put in. So we use sensors today in our day-to-day life, and we use several sensors. Usually one sensor gives you good data, but it's not always enough. So the trick is to use several kind of sensors and do some sensor fusion, which is what we'll show next. And then sensor fusion is really based or modeled on the human model. So us as human, we have a lot of senses. I mean, you all know our 5 senses that we all have, hopefully, and we use that all the time, more or less in automatic way. And we use, the key point is that we use several senses in our day-to-day life. Like if you're driving a car and you start to smell some things burning, maybe you can see some flames. So you use vision, you use smell. You can use your finger to touch something, see if it's hot or not. Depending on, you can use different type of sensing information to make the smarter decision, which is maybe you need to leave your car right now, or you have time, you can call somebody. But that's a model. And really the point is the world is greater than the sum of its parts, so using information that complements itself. Another example, pedometer. So you can use that when you're running. There are simple devices that you can just put on your belt and that counts how many steps you've done every day. And it's like a little gadget. It is actually quite interesting and funny in my office, in my US colleagues that start to wear some of those. Usually when they wanted to book a meeting, they always book the meeting room, which is as close as possible to the office, and we have a large campus in Austin, Texas. When they start wearing the device, they were booking meeting rooms as far as possible to their office so they can walk more and they can increase their days, steps they make every day. So it actually works. Now, the pedometer, if you wear it on your belt, you can see the examples of 3-axis accelerometers reading. You have the X, Y, Z in different colors, and every step you make, you can see the sensor will detect it. Usually there are 2 axes which are well detected. The 3rd axis is less important because it follows your motion, and it works well. Now, if you want to turn your device into counting the calories you're burning, well, knowing how many steps you've done is good, but maybe not good enough. And maybe you want to wear the sensor on your arm because you're running, and that's where you put your iPod or whatever, and you want to put on your arm and not on your hip. In that case, you have another movement that you need to compensate. So you need to put a gyroscope to compensate for angular motion. And if you're running upstairs or you want to walk upstairs as your training exercise, well, it's not the same thing, going upstairs than just walking or running. So you want to measure altitude, so you can put a altimeter. We'll also make, very small altimeter devices. Now you could be, measuring if you're going up or down. And all that with like 3 sensors, now you can build a really smart calorie counter device that will count, your exercise regardless of where you wear the device, and also counting into account if you are moving up or moving down. So more sensors give you better result, better experience. And good experience really means the consumer will adopt the device, because nothing is worse than something that fails on delivering its promises. So all kind of sensors, I mentioned accelerometers, gyroscopes, magnetometers. Usually those are 3-axis sensors, you know, the 3 physical dimensions. And we start also to combine those into smaller, and we combine also the sensors into the same package. So now you can buy in one 3x3 millimeter package 3-axis accelerometers and a 3-axis magnetometer. And with those 2 technologies, that's what you need actually to build a good electronic compass. So electronic compass, you need the accelerometer to compensate for tilt and motion. You need some calibration software to eliminate perturbations from close by magnets or piece of iron. And with those 2 sensors and right software, you can build a good electronic compass. Another example, gyroscopes also suffer from drift over time. So if you have an accelerometer, you can use that data to compensate for the gyroscope drift. Temperature sensor, altimeter device also need to be compensated for temperature. So you need a temperature sensor to compensate for a good elevation reading. So again, we need to combine all those sensing elements to give a good experience and a good result. So what we've done to make our customers' life a bit easier is we have those hardware. We filter the data that we measure from those sensors. We calibrate it, and then to help for the development and the usage of those devices, we produce basic drivers like this one was done for Windows 8, but we also have that available for Android. And you can plug a evaluation board into the PC or the tablet. It would be more likely like a tablet in the case of Windows 8, and you can start developing using the sensing technology. So why do we need that? Why do we need that sensing information? So us as human body, it's easy. Our sensors are everywhere. I mean, somewhere in our body, and then the brain is the cloud, and then we decide, or we react with automatic reaction. But in the case of machines and the Internet of Things, we want to collect that sensing information to give and feed information upwards towards the cloud of about us, the human being. What are we doing? Are we moving? Are we reacting to something? In what state are we? Is my heartbeat, calm or activated? Maybe it's activated now because I'm speaking here. Am I sweating? You could sense also that. In the case of gaming activities, you could have game controllers that detect if your heartbeat is going high, if you're shaking a lot, if you're sweating maybe a little bit, you're nervous. So maybe the game will be tougher for you because usually it's better if you're calm than nervous. Those kind of things you can measure. Same thing for the machine or the infrastructure you're in. If you're in a car, is it moving, not moving? And then the environment, the temperature, the light, is it night, is it daytime, whatever, where are you, which altitude? So all those information is captured and then sent upwards to the cloud. And this is how we picture it in one slide. This is you could call that the Freescale view of Internet of Things. How we see ourselves providing the basic technology blocks. I'm talking about sensing here today. We will also make processors, MCUs, MPUs of all kind of and different class and power, and also connectivity that we just talked about earlier. And all that technology is really feeding all those smart devices or smart applications. The smart parking. I think we saw some smart parking device here on the stand. You can see that. Robots, smart farms, smart cars, smart lighting, etc. So all those applications that we call the Internet of Things, with embedded intelligence, are capturing this data and then using it to provide smart services. And as those devices, those applications are developed, there is new innovation, new technology needs that are discovered, and that kind of close the loop and feedback. We take that feedback and then we try to build smarter components, smarter semiconductor to sustain the Internet of Things. To picture that differently, for us component makers, we see the need coming from the nodes which are close to the body, to the machine, to the human, where you have sensing, where you have some low power processing, and then you have connectivity nodes. We've seen earlier the smart box in the home, so you connect to that, wires or wirelessly, and then you go up the chain into the network and finally up to the cloud. And we support that. You recognize, Zigbee, Wi-Fi, microcontrollers, higher class microcontrollers, some protocols for communications, and then really powerful network processors that will compute all that data in the cloud and do something with it. This is basically, looking at the same thing again. All these context awareness or contextual information that is collected, that it's transmitted through different technologies, either processed locally. Sometimes you want to process locally things because there is an emergency, there is something you want to do quickly, that's fine. Sometimes it's more about collecting data to the cloud, sending it, and then doing something with it later. And really these collections of contextual data, is difficult to say, it's really helping the cloud and the big data processing because you want to know more about what's really happening so you can make the right decision and then send back the right information, the right decision. Like the example here of online ordering, how many times you look for changing your car tires, for instance, and then you're bombarded for like the next month with offers for tires and tires and tires, and okay, I've bought my tires now, leave me alone, send me something else. So that's dumb information being sent back to you. Now with better contextual data, you can really drive better applications, better information being sent back to you. So these can find applications in all type of industries, factory automation. I think there is the FANUC demonstration here on the show. You can see the robot picking up objects, placing them correctly. It's kind of local processing, but sometimes maybe it's picking another piece of thing that's not supposed to be there. If it's connected to a higher level of processing, maybe not all the way back to the cloud, but at least to the office central computer, you could recognize this is the wrong device and do something intelligent with it. One example. And then we could talk for hours about smart grid and smart traffic and smart agriculture and smart lighting. I think it's pretty obvious, the needs of really sensing what's happening. In the case of smart grid, are you home? Do you have an electric car? Is your electric car plugged in? What time of the day it is? Is it hot? Is it cold? I mean, all those data can be used to drive a better decision on how to manage the smart grid, for instance. And same thing with their other aspect of improving our day-to-day life with traffic, with lighting, smart agriculture. I think we see some small robots for agriculture here on the show also. Wasting less chemicals on the ground, for instance. So the other area where Freescale is also investing a lot is the automotive, since automotive is our largest market. And lots of work for car-to-car or car-to-infrastructure communication. This is also something that's being also harmonized and standardized through ETSI and other organization bodies throughout the world. And really, like, you can have a bridge that monitors the temperature of the ground, and if it's freezing, it will communicate to the car that's coming towards the bridge that there is a it's freezing and there might be ice on the bridge, so you want to be careful and not put yourself in a dangerous situation. Or car-to-car communication for adaptive cruise control and better safety on the roads. Same thing with medical applications and lots of application really where better information will lead to better services. So that really, to summarize it, this intelligent contextual sensing, leveraging sensor fusions, again using several types of sensors to come to a better decision, a better feel of what's really happening, and then feed that up to the cloud through different protocols, wired or wirelessly, and then enable all those smart services that we may like or not like, depending on where we are and what we do, but really helping at the end our day-to-day life. And that's another way to see it. As we like to see the basic technologies of pressure sensors, magnetosensors. This is radar technology, temperature sensor, accelerometers. And the foundations to really help increasing level of intelligence for a smart Internet of Things. And I will leave you with that sentence as the conclusion. All right.
So, thank you very much, Yves.